All right, so welcome to Fluid Mechanics. This is the first example of Chapter 2, but even though it's the first example of Chapter 2, it's really the first real example of the book because Chapter 1 was just a bunch of unit conversions in like basic units like, the kilogram or whatever. Um, so this is as elementary of an example as you can get. Uh, we're going to learn how to calculate the density, the specific weight, and the specific gravity of an oil. So let's get to reading the example. Um, so a reservoir of oil has a mass of 825 kilograms. The reservoir has a volume of 0.917 meters cubed. It wants us to compute the density, the specific weight, and the specific gravity. So let's start with the density, okay? We're only going to be applying the definitions here, which is in the form of a formula, of course. So what is the density? The density is, and this is of the oil that we want, it's equal to the mass. Okay, so that's just the definition of density. It's how much mass shoved into a unit of volume. So mass divided by volume. So the mass that we're given is 825 kilograms. So let's just put the equal sign. So this is equal to 825 divided by the volume of the reservoir, which is 0.917 meters cubed. And that's pretty much it. That's the density. It's equal to 900 kilograms divided by meters cubed. And that's our density. So the next part of the example or the problem is that we need to find the specific weight. So what is the specific weight? Anything specific is usually just something divided by the volume. That's why it's specific. It's per volume. So specific weight, gamma, is equal to the weight divided by the volume. Now, as you know, the weight is also the mass times the gravity. This is from Newton's second law, F equals ma. This is the force of gravity. The mass is the mass, and the acceleration is the gravity, divided by the volume, right? So the weight is mg. Now, since this part right here is the exact same as this, that's just rho. So this is equal to rho times the gravity. Since rho is 900, what we can do is say it's 900 times the gravity, which is 9.81. And that equals 8,829. So this is force, so newtons, divided by meter cubed. All right, so far so good. What about the third part of the question? So it wants us to find the specific gravity. The specific gravity has actually another name. It's called relative density. So specific gravity is the relative density, which means the density of the oil we have is 900 relative to the density of the water. So let's calculate that. This is the specific gravity. Specific gravity, it equals the density of whatever we have in comparison to the density of water at 4 Celsius. So that's the standard temperature. So it's 1,000 kilograms per meter cubed. So this is going to give us 0.9. And that's our example. We found the density, the specific weight, and the specific gravity of the oil.